All right, first term here I want to go over. All right, before we start problem number one, elevation. All right, angle of elevation. You're going to start seeing that term in these word problems. And where does that angle go in a triangle? Elevation is you're on the ground. You are on the ground. Here's the start of it. There's your grass. It's about as much as I do here with the. There we go. You're on the ground looking up at something. Buildings, trees, whatever. You're on the ground looking up, let's say a building here. A little window action there for you. All right, looking up at the top of it. You form an angle of elevation. How is this angle formed? Well, you're looking at the top, so there's one side of the angle. Where's the second side of the angle? Your horizontal line of sight. All right, I just formed right there what's called an angle of elevation. You looking up at the object along with your horizontal line of sight. That's called your angle of elevation. Do you see the right triangle I'm forming now? Everyone see my right triangle now that's formed? All right here. So there's my angle of elevation. So let's see if you guys can help me here in problem number one. Design it. We got Big Scotty here on problem one. His eye level, 1.5 meters above the ground. Go ahead, throw the 1.5 on there. Where's 1.5 meters going to go? His eye level, 1.5 meters above the ground. Eye level. So ground to his eye, 1.5. So I'm going to stick that 1.5 over here to his eyes. And he's 30 meters from the tree. Let's throw that 30 meters on your diagram. He is standing 30 meters from the tree. So let's put that 30 meters right down here. All right, 30 from the tree. All right, here's our new term, angle of elevation. So you know he's looking up at something. That angle of elevation, 36 degrees. How do I form the 36? Ready? From his eyes to the top, along with his horizontal line of sight if he's looking straight forward. That forms a 36-degree angle. Okay? Looking up. Elevation is always looking up. 36 degrees. You see the right triangle you're going to form now. All right, drop that vertical line right down, and we got ourselves a right triangle. But here's the problem. We're looking for, hey, how far above the ground is that bird? All right, ground to bird. What are we looking for there? Ooh. All right, first thing, do you know a side? I know the 36 degrees. Do you know a side in that right triangle? Do you know a side length based on everything we wrote down and labeled? Do you know a side length? Any one of these three sides? Do you know the length of one of them based on everything we labeled on the diagram here? All right, let's turn it over to you guys. Do we know a side length? Not here. Let's go 9. Vinny, do you know a side length?
Yeah.
What side?
Adjacent one.
All right, yep, go ahead.
It's 30.
Good. I like your vocab. This is 30 right here. All right, his distance from the tree. Good, Vinny, yep. But here's what I'm looking at here, though, guys, and maybe you can help me out with this. There's no way I'm going to find the bird to the ground in one step. Can I find one side here and maybe use that side to find the distance from the bird to the ground? Because I'm not going to be able to set up sine, cosine, tangent, solve for ground to the bird. No way. No way. Is there a way I could get to it, though? Is there a way I could get to that length by finding a side? Plan it out for us. Help me plan it out here. Finley? Remember, he's 1.5 meters above the ground, too. Could we find a side length at all and use, go ahead.
The opposite side.
Yep, we could find this 8. Let's find this side. Not going to get us our answer, but what do you want me to do at the end? Add. Okay, we got a plan. Everyone go with our plan? Find the opposite side, add 1.5 to it. We got our distance. All right, we got our distance. All right, Finley gave away half of it already. We're going to find the opposite side. How about the 30, though, Vinny gave me? What's that? That's going to be what side to the 36? One's, Micaiah, what's that going to be? What side's that? Yep. Adjacent side. All right, so you guys go through SOHCAHTOA. If I have opposite and adjacent, which one of the three ratios can I use now? Sine, cosine, or tangent? If I have those two sides. Lauren?
Tangent.
Tangent, good. abbreviate it TAN. 36. Still asking a lot of questions of you guys. What's it going to look like on the right side? Opposite over adjacent. What side you going to put together here? Alexi?
Oh, you're gonna put X over 3.
Good. And we make this into proportion just like we've been doing for 3 days now and cross multiply. As you're doing that, what you're looking at the calculator, is that your final answer when you do tangent of 36 times 30? Is that my final answer? No, the only reason I ask that is because we are not rounding it then. If it's not your final answer, you don't round it. Make sure you're in degree mode too. I don't know who's been using your calculators and if they're playing around with it or not, making life difficult. Again, I'm going to write it out myself, 21.79627,584. Write it all out because that's not my final answer. And like Finley planned out for us, hey, that's just the opposite side. I still got to add in that 1.5, which is his height. And when you have that nearest 10th, let me know. Henry, good talk. Lauren, back to you.
23%.
Good. Good work. Also, I'm not a stickler for units. You want to put them on, you put them on. If not, I'm never going to penalize you for it. Any questions on elevation? Looking up, line of sight. Looking up, line of sight. Go ahead, Lily. What's up?
So I just have a question. So if we said x equals 23.3, isn't x the opposite side? So would we use if we're answering the question, would we?
Yeah, I get you. Maybe we should have called it y or something, a different variable.
I was just wondering.
No, I'm all right.
Okay.
Yeah, don't worry about that stuff. Yeah, I see what you. Yeah, I probably should have called it y. Other questions? Okay, let's reverse the roles. I told you there was 2 vocabulary terms today. You found out the one, which is elevation. Now, before we get to problem number 2, now instead of you being on the ground, you're going to be at the top of the building looking down on something. So get the old building back. All right, so there you are. For whatever reason, you're on top of the building. You're looking down. Let's say you're looking down at the dog down there. I don't know why he's got a wing hanging off, but he does. All right, so you're looking down, but there's going to be a problem we run into. You guys think like this is my level right now. There's a reason why I took woodworking in high school and not any art class, and this is the reason why. So going on. You're looking down now, but I'm going to run into a problem, and I need your help before we do number 2. So you're looking down, right, at whatever object is on the ground. And where's the other side of the angle? It's from your horizontal line of sight, just like the elevation was. So take a look. This right here is your depression angle of depression. All right, that's your angle of depression. So what's the problem? Here's your problem. Here's the right triangle I make, right here, this yellow one. Notice where the angle of depression is. It's outside. It's outside. I can't use it unless it's inside to use sine, cosine, tangent. So I need your help before we start an actual word problem. I'm just going to throw this out. Say it's 30 degrees. Angle of depression is 30. That's where it is. But you can't use sine, cosine, tangent yet. I need an angle that's inside the triangle. Is there any way you can use that 30 to get an angle that's inside the triangle that I can actually use now? Because that right there, I can't. We're not doing sine, cosine, tangent yet unless you get me an angle, an acute angle that's inside the triangle. So can you use that depression anyway to get an angle inside? That's my question. Because we're stuck right now. That's where the angle is. That's how I locate it, but I can't use it. Yes, Stone.
Is the angle adjacent to it complementary?
Correct. There's one way, right? This angle right here next to it is adjacent. So we could say that's 60. And anybody remember from early in the year, These two angles here, alternate interior. Good. So they're congruent. So either you can say the adjacent angle is complementary or it's equal to the alternate interior. Your call. Only do one though. Your call. All right. So let's go back to number 2. We got Big Al on top of his building, watching his friend approach the building. That's kind of creepy, but it is what it is. Angle of depression's 40. Ready? So he's looking down at his friend along with this horizontal line of sight. That is 40. Always make sure your angle of depression is located outside your right triangle. All right, what else do we know here about Big Al? The rooftop, 16 meters from the ground. So rooftop to ground, 16 meters. Just this right here. Just that right there. And then Big Al's eyes, 1.8 from the rooftop. Got it. And we're looking for what's the distance between Big Al's friend and the building. So his friend building, we're looking for that distance, it looks like. All right, so find your right triangle you're going to use. All right, find the right triangle. Looks like it's right here. All right, you make the class decision right now. What do you want to do with the 40? Because I can't use it where it is. We talked about 2 different ways you can put it inside the triangle, but I can't use it where it is right now. All right, class decision here. Bryson, where do you want to do with it? I need it inside the triangle, so we just discussed 2 different ways we can put it inside the triangle. Which way do you want to put it in?
Oh, like alternate interior.
Okay, so if that's 40, I'm going to put a 40 right there. If anybody wants to put the 50 next to that, you can do that too. It's fine. We're still going to get the same result. All right, so if I'm going from that 40, I need to know what the x is, the side we're trying to find. Even if you didn't do it this way, we could still try to find it. Finley, what is the x? Opposite, adjacent, hypotenuse in our diagram. Adjacent, good. And then how about Big Al in the building? That'd be what side to the 40? Jared? Opposite, good. So it looks like I can use which ratio? Stellan? Tangent. And even if you put the 50 next to it, you should still be using tangent. Just opposite of what we're going to write here. So tangent of 40. Now here's the hiccup. Did everyone realize you can't use 16? You got to do 16 and 1.8, and that is your opposite side, right? Hey, right? Look at your right triangle. It's the 16 and the 1.8, so I got to combine them. So somewhere in your ratio, whether you use 50 degrees or 40 degrees, you should have in 17.8 somewhere. And then x as your other side. Why am I dividing by 1? Hey, if you use the 50, you should get the same answer here. We're going 10th again. Here's 10. All right, when you get there, let me know. Nearest 10th, how far away is this friend? Stephanie?
21.2.
Yep, 21.2. All right, questions? All right, you and your group, you got the next 2. First one is depression, next one's elevation. Can't wait to see your airplanes and control towers on that last one. All right, yes, I will be walking around critiquing. I'll put the answers up here for you. If you get stuck or you can't get the answer, let me know. Feel free to discuss it with your group, though. Shoot. You know, just do number 3. There's a vocabulary term on number 4 I need to go over with you. All right, so just do number 3. Get number 3, and then we'll talk. All right, stay away from 4. I forgot there's a vocabulary term there we need to talk about. So make sure you can get the answer 200.6 here for number 3. Make sure when you draw your diagram for number 3, depression is outside the triangle. And then you put it in, deciding however you want it. And as you decide what ratio to use, hopefully 28 or 45 are not in your equation. You can't use either of them separately. So make sure you don't put 28 or 45 into your ratio. Hopefully here you go, use the tangent ratio. I did 70. I did the adjacent angle to 20 equals x over 73 by adding 28 and 45. The only difference, some of you may have used the alternate interior angle of 20, and then it should have been 73 over x instead. Any questions there before we get to 4? All right, 4, I'll set it up with you, and then I'll let you solve it on your own here. There was just one vocabulary term I wanted you to know where to put the number. So we got elevation now, so we know we're looking up at something. We're looking up at an airplane from a control tower. All right, so control tower, looking up to the airplane, that's a 7-degree angle of elevation. Hey, let's see those control towers. Here we go. This should be good. Let's see those control towers, kids. It's the big thing at the airport they view the planes from. See what this looks. This should be good. Don't take the easy way out and just draw a vertical line. Let's see them. Let's see them. Here we go. Who's going to be majoring in art?
Pretty good one.
Yeah, drew a guy smiling with the top hat. That's good. Yep. Good. Alyssa's got it dropping a spider web down. Yep. Good. And he's got the UFO at the top. Yeah. Lily's got the classic hammer going. Good. All right, draw your airplane. Now, draw your airplane. Can you make that angle 7 degrees of elevation? 7-degree angle of elevation. So remember, it's looking up, right? From here to the line of sight. 7 degrees. 7 degrees. And yes, some of you guys are already making your right triangle out of it, which is great. All right, a couple other things. All right, the control tower is 200 feet high. Here's the vocab I wanted you to go over. We'll go over with you. The altitude is 5,200 feet. That means the plane is directly above you from where you are on the ground. So here's the plane directly above you to the ground right here. This distance is your altitude of 5,200 feet. Altitude is always wherever the plane is, directly down to the ground. That's how far above the ground it is. So 5,200 feet. And what do we find in the diagonal distance? Diagonal distance. Last problem you guys had what? The horizontal distance. Now I want the diagonal distance from the plane to the control tower. So I don't need this part. That's the horizontal. I'll tell you, I'll put the word in there. I want diagonal distance. So it looks like you guys are going to have to figure out what to do with that 52 and 200. Because I do not know any other side length. And I'm just going to leave it at that. Let you and your group or you by yourself play around with that. I'll throw the final answer up here, but that's about it. Okay? You need at least another side length before you determine if it's going to be sine, cosine, or tangent. And then once you match the answer here, feel free to start the word problems. But you're going to have to figure out how to find a side length before you determine sine, cosine, or tangent.